folks. Welcome out there on this great Friday afternoon, already the end of the week. And you know what that means? We have some specialized segments here on TNLearn Mathline. I'm Ernie Roberts. I'm your host for this afternoon's session of TNLearn Mathline, where we are going to let you lay back, relax, do some math, get your pencils, get your paper. And I don't know if you need a calculator today or not. I don't think you will, personally. But what we want you to do is just sit back. We're going to have a tutorial type session today. I have no idea. I do have an idea. We're going to see what the topic of the day is here in just a second. But we're glad you're here with us today. Again, it's not a call-in Friday, but you can still send us emails. You can still send us Facebook messages, all those great things. And we'll be back live again on Monday, all right? But anyway, let's have some fun today here on TNLearn Mathline. What are we going to have fun with today, guys? Oh, it's an or, it's an and. It's like Superman. It's a bird, it's a plane. Who knows? I don't know, is it? Well, we're going to look at it's an or, it's an and. What in the world is that all about? Sounds like combined inequalities to me, all right? We're going to look at what happens when we have an and situation with two inequalities and the or situation. We're going to just graph a little today. And when you say, how are we going to graph, Ernie? We're going to be on number lines, all right? So like I said, today I don't think you'll need a calculator. If you do, just don't tell me, okay? Hey, let's see what we've got going. What's my first problem going on here? We are going to try to graph for you x greater than -2 and x less than 3 on a number line. Now, you notice I've got two number lines here, and I'm going to have a third one coming up for you. Well, what we want to do is look, what does this look like? And then we're going to illustrate and talk to you about what is this little guy and all about, all right? What's going on there? So on my first graph, I'm going to try to keep the scale pretty much the same. And again, our numbers are very reasonable. And we're going to talk a little bit about it once we get to the final point here. Let's see what happens. First of all, I'm going to find -2 on this first graph. Right there it goes. And I am going to try to shade x greater than -2. All right. Now, open circle, remember, folks, because we don't have equals to on these. So we're going to put an open circle right there for that -2. And according to this, we're going for greater than. So let's go greater than to the right, to the right. There we go, there we go. All right, boom, 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 boom. Boy, it's a long way to the end. And then remember, we kind of darken that edge because it does keep going on and on. All right, ooh, that looks a little messy darkened there. All right, there we go, a little bit better. It keeps going, all right, it keeps it going there. Now, let's look at our next one here. It says x less than 3. So somewhere here, I'm going to put a 3, about right there, okay? And we're going to open circle there because it's not included. There's not an equals to on that. And we're going to shade this one back to the left. All right, so I'm going to go ahead and do that part first so then it doesn't look so messy when we get there. Yeah, there we go, there we go. Keep shading all the way back here to 3. Now, point before we go to the next line. Hang on just a second, guys, on that. Oh, there it is. That's all right, we got it. I want you to notice something here. We got real close to -2. I didn't stop at -1, all right? Nor here did I stop at 2 and say we're going to leave a gap. This whole shading business takes us all the way up to that open circle, which represents the exact amount of -2, the exact amount of 3. And you say, well, why is it important to know that, Ernie? Because it's not just about integers. We think of numbers that are greater than -2. We think, okay, -1, we go 0, we go 1, 2, 3, you know. Those are the integers, but there's all that space in between. And there's also a lot of space between -1 and -2 that has to be shaded. So understand, that's first what we're doing. Now, the key word here, and we have to make both of these work at the same time. So we want numbers that overlap these two graphs. Now, if you look right here, there is, let's see if I can keep that from moving. There's our cutoff point, but here's our cutoff point. Everything in between these 2 points is our solution to this problem, all right? So let's come down here on our third graph and let's put a -2 and let's put a 3 there. And you know what? We got open circles at both of those. Where do these two graphs overlap? Between -2 and 3. Let's cut it right through there. And by the way, there's another way we can write that. We can write that -2 less than x less than 3, all right? And that's another way of saying that basically x lies somewhere between -2 and 3. You can check your answer very quickly using the integers for all things. You know, 0 is, wow, it's greater than -2. It's also less than 3. and it's in that shaded region. All right, so they're easy to check your number lines. They're good things. All right, so there we go. That's the storyline today here. We're going to make two graphs, and we're going to combine them, some size, shape, or form, using the concepts of and, also with or. Okay, I had to watch out for that. And or. It kind of sounds strange. So let's take a look at our second one here. Another and, which means we're going to be looking for overlapping. All right, so let's go ahead and put our first two graphs together. This one says we're going to start at 4. So I'm going to kind of take it up here. And it's open circle. So let's do just that. Put an open circle there. And it says less than. We're going to shade it to the left. All right, so here we go. By the way, we make that edge over there a little bit darker. And that keeps going, by the way, folks. And it comes back to as close as we can get to 4 as possible. All right, still keep that open circle so we know, including the number 4. Now, let's take our second graph, which starts at 1. 1's a little bit back here to the west, okay? Now, I understand I'm not exactly centering 0 on these, so hopefully you're seeing that. But we are going to keep it relatively speaking here, number-wise, where we are going to put our numbers as best we can. I didn't do that on this one, so don't get too upset. That's where we are. Now, at 1, let's go, closed circle. Why closed circle? Because it's got an equals to. Got an equals to there, all right? So let's take it out here to 1. It's going to be greater than. So here we go. We shade to the right. And let's take a look at where these things overlap now. Where do they overlap? I've come to the conclusion I do better going left than I do right on shading, okay? So let's see here. We are between 1 and 4. So let's bring that to our next graph. Bring the 1 straight down there. Bring the 4 right there. It's open circle still, my friends. This one's still closed. And what we're going to do, we're going to see where does this overlap. Well, it overlaps right through here, in between. There you go. Combined inequality, how do we write it? Well, we write it 1. How about it? Less than or equal to x less than 4. All right? So there's your situation, and there's another way to write the combination with and. All right? So that's our storyline here. Let's do some practice. All right? We'll look at some practice problems here. How about our next little guy here? This one says, let's see if I can bring it down there. There we go. Got graph x less than or equal to 4 and x less than 0. Now, sometimes people get all excited about x less than 0. So what does that mean? That basically means all the numbers are negative. All right, they're going to be all to the left of 0. So I'm going to put 0 right in the middle this time. So those of you who get real excited, you know where you're going. So let's put it up here. Let's start here with, first of all, x less than or equal to 4. Here is our value with 4. It is a closed circle. We will do just that. And according to this, we're going to shade to the left. I like those. I like those. Shade to the left. And we'll darken that up just to show that it keeps going, keeps it going. Now, on the second one here, we also have it 0. So I'll put 0 kind of right as close to the middle as we can get it there. All right, pretty close anyway. And let's see what's going to happen with 0. We're also going to shade. We're going to open circle first, though, and we're going to shade it to the left. And you say, well, Ernie, they didn't go different directions this time. You're right. They don't always do that. Okay, sometimes they go in the same direction, and that's what's going on right here. But yet we want to see where do they overlap. All right, there's no overlapping certainly out to the right. Okay, and we don't see any overlapping until we get just beyond 0. So our pulling together here, folks, where do they overlap? It's going to be that open circle at 0. We're going to be shading to the left. And there we go. Now, I think some of you probably are very astute out there. I know you are because you're watching Mathline on a Friday afternoon. And you're also noticing, my goodness, it's the same as that one. All right? That can happen. That can happen when they're overlapping and going in the same direction. That's going to happen because they keep going here. They don't stop at 0. They don't stop at 4. They just keep going in these individual ones. But where do they overlap? From 0. On out there. Now, 0 is an open circle, so we can't put an equals to on it, all right? We got to leave it with that less than 0, all right? So basically, our solution on this one, x less than 0, that's how it would combine together, okay? No need to write anything about this 4 because it's not where it is. It's happening from 0 on over, all right? So they can go different directions, They can go in the same directions, all right? So let's see what's going on here. How about another one going in the same direction? Let's get a little practice on this one also. We've got x greater than negative 2. Let's put that one up there. Here's negative 2 somewhere to the left. And it's a closed circle. Closed circle, folks. There we go. Now, we are going for greater than this time, so let's do it. Go greater, go greater, go greater here. Here we go. And we'll darken it up a little bit on that edge. Ooh, I did much better on that one. Now, don't play with it too much. It'll be a mess. All right, now let's see our next one here. We're going to start at 1. And we're going to close that circle, and we're going to the right again. Now notice these are going in the same direction. That's okay. That's okay. Things happen. That happens lots of times, all right? Doesn't always go in separate directions, all right? But this time, again, it's an and. So we are looking for where do these graphs overlap. So I move along here, and then, woo, there it is. Right there at 1. 1 is where they start overlapping each other. So our solution, when we come down to our third graph here, is going to be 1, and we're going to shade it to the right. And that's going to give us, looks like what, x greater than or equal to 1. So there is your solution. That's your combined inequality. That's the and part. Now, some of you probably ask me, Ernie, do we always have to have 3 lines? I think it's good to start with on 3 lines, but after the end of this lesson, hopefully you start to see some things that you're looking for, overlaps, and you can do that mentally, okay? You can do that mentally and go straight to this final answer. But I think it's great to see this visual along the way of the 2 graphs basically merging in some way to make one graph. In this case, we're looking for them to merge with the overlap, okay? Now we're going to say, in this case, right, remember I had that little word or, that's a different story. That's a different story. So we'll get to that in a minute. Let's take a look at one more here. Let's look at this and situation. All right. Let's see what we got going here. We have graph x less than negative 4 and x greater than 2. Story on this one? You say, well, Ernie, one's going one direction, one's going the other. You're right. Let's see what happens. I'll put negative 4 here. By the way, it's an open circle this time, and we are going to take it off to the left. Shade off to the left. We'll darken that edge in just a little bit. All right, so we know it's going that way. Take a look at this one. X is greater than or equal to 2. Find a 2. It's somewhere on the right, so to speak. We'll open that circle. No, we're going to close it because it says equals 2, doesn't it? All right. So let's put a nice greater than shade. That goes to the right. And remember what I said. We're looking for where do these overlap. And if you'll notice something, my friends, they don't overlap. You say, well, Ernie, what do we do? If the word and is there, we can't do anything. So let's go to our bottom line here, and we're just going to say there is no solution. Because no matter how hard you try, you're not going to find any numbers that are less than negative 4, and also at the same time, greater than or equal to 2. They don't exist. They do not exist, all right? So that's just a huge gap. No solution. No solution. That's how we work that, all right? So you say, wow, that one's interesting. It was. Now you say, is that always going to work with the ors? Well, let's take a look. Let's look at some of our or situations, all right? Now, we're going to start with these. We're going to take the word or. That means I could find numbers that are less than negative 3, or I can find numbers that are greater than 0. They do not have to satisfy both of those conditions. In fact, if you found numbers that were less than negative 3 and you find numbers that are greater than 0, there is no overlap. That's not what we're looking for. With the or, we're saying, hey, that can work or that can work. So we've got 2 options for solutions, and they're both good. They're both going to be good. So in other words, we're not throwing anything out on these. We're not going to throw anything out. So let's take a look and see how this works. First of all, our first little guy here is x less than negative 3. So over here, I'm going to find a little negative 3. There it goes. And we're going to open that circle again. Open that circle again because there is no equals 2 on this one. This time we're shading to the left. And you know what? We're going to keep going. To the left. To the left. Now, Come back, let's find 0. I'm going to put it toward the middle this time. See if I can do it right. There we go. We're going to open that circle, and we're going to take it. This time it says greater than, so we're going to the right. To the right. Greater, greater, greater there, all right? And we'll try to darken our edge a little bit more to say, hey, we keep going that way, all right? Keeps it going. Now, as we said, we don't throw anything out on these. We don't throw anything away, friends, on this with an or. We keep everything. We want numbers that are less than -3. Sorry, -3.5, -4, -6, -1,000,000. All those are good. I get the fractions in there too, all right? I did mention a fraction. All sorts of numbers here, all right? Also, we don't throw these out. Any number that's positive, any number that's greater than 0 is going to work, whether it be a decimal, irrational, rational, all those good things. Any real number works. That is a positive real number. It works, all right? So what are we going to do when we graph it? We're going to bring them both down just like you see them, and we're going to put them on the same graph, all right? So there's -3, got that? And here's your 0. Open circle still, that didn't change, all right? And we're just going to shade them together. And see how that's working, going one way. See how this is working, going this way. But we don't have any, oh, but we do, don't we? We got to put that in there also. Some of you were about to say, wait a minute, can you do that? Sure we can, because we're representing both graphs. And how would we write that? Just what it says. This would simply be, we can't, and this is a point I need to make to you, everybody. It would be x less than -3, or, yeah, in this case, we don't jam them together. It's not going to work. It's not going to work. The only time we can jam them together in a nice one middle thing is with and. So good point, combined. And this combined has to have the word or, and it's going to be x greater than 0. Because we're not falling in between these. In fact, we're going outwards from it, all right? So we're going to the left on one side and to the right. And like I said, they're all good answers because all we have to do is make one thing work at a time. One thing. That's why the word or is there. So you get to keep everything. You get to keep everything, all right? So there's our first illustration. Let's take a look at another example here, all right? Let's take a look at this example. We've got x less than or equal to. Okay, we've got those equals to back. So that means we're going to be filling in some circles, shading in. And according to the first one, let's do our first one here. It looks like it's a +1, and we got a -3. So I'm going to put my +1 right here. And according to this, it is less than +1. Everybody see that? Your eyes are not deceiving you. That says less than. So here we go. So we're going to the left. So let's pop it in there. Come back to the right. And yes, we keep 1. So it's going to be shaded in. Closed circle. Now let's take a look at our next one here at -3. That is a negative. All right. Not just a little splotch on the paper here. That is a -3. Let's find -3 somewhere on this second number line. There it is. And wow, we're going to go to the right. We're going to go greater than. Go greater, go greater. And we'll darken up the edge there. So what we've got going here, is an or. So that means I'm going to pick up any numbers that are less than or equal to 1. Well, that's all these guys. And greater than and equal to -3. That's all these guys. Goodness, we've covered the whole number line. The whole thing is there. This is a crazy answer? Well, it can be. This one is going to be everything. All real numbers. We'll just put the -3 in there just for those of you who like to see them. There's the 1. But we just go blasting right through because they're already included. Those points are already included. So this one, dear friends, the solution, all real numbers. Pretty cool. All right. So now remember, back on the and, we had that one situation where we couldn't get anything. With this or, actually we have this opportunity for everything. All right. So there's always going to be a solution with an or. Sometimes it's incredibly huge, all right, like everything, okay? This one is what you got to watch out for, all right? So we're not looking for the overlap. We're looking for describe all the possible solutions when we have an or. It could be the less than part, it could be the greater than part, and it just so happened they overlapped each other and included everything. Everything on that one, all right? That's where our ORs are working. Let's take a look at our next one here, all right? We've got x greater than -4 or x less than -1. Sounds very similar. Sounds very similar. Let's see how it works, all right? This time it's open circles. This time it's open circles. I want to make sure that we understand that sometimes that makes a difference, and let's see what goes on here, all right? So we're at -4. I'll pop a -4 there. Right here I'll put a -1, and we're going to put open circles there, so I don't forget those, all right? Now, this time, greater than -4, we are heading to the right. There we go. And this time on the -1, we are heading to the left. All right, so we'll darken that arrow, and we're going to take it right there to the left. Now, some of you are saying, well, that looks kind of like the last problem, but what do we do with those open circles? That's exactly why I wanted to bring this problem in, all right? What do we do with the open circles? Number one, if you are going to the right, you have picked up -1, all right, in this part. Here, when you're going to the left, you have picked up -4. So again, this is going to be everyone got hit at least one time, all right? So even though we have up here with this -4 and this -1, we have open circles when one graph comes down on top of the other, or vice versa, however you want to put it here, they're going to take care of each other on all those numbers. So again, this one is opening up as all real numbers, all real numbers. And again, notice what happened. We just plowed right through that -4. We plowed right through the -1, and we get all real numbers here, okay? So that's your storyline on this situation. Remember, I said with OR, you could have everything. And sometimes with the AND, you could have nothing, okay? And most of the time, we're going to be somewhere in between. We're going to be somewhere in between with most of our problems, but I wanted you to see those situations. Let's see what's going on here. How about it? Looks to me like, woohoo, what do we have? We've got x greater than 2, all right? And then we come back and said x less than 2, but it's an OR. We got an OR, all right? So let's take a look at this one. Kind of interesting. Not kind of, it's very interesting. Let's put 2 here kind of close to the center. And it's an open circle. And the 2 down here on this next one is also open circle, all right? So we're going to go greater than. Let's do it. And here we go. We get that working. And this one, we're going to go less than. Get that thing working. And it's an OR, which means I include everything from both of these graphs and basically glue the graphs together. And if you'll notice something, everything is almost all real numbers with the exception of what? Everybody got it? Everybody looking? 2. 2 is an open circle right there in the middle. We will shade go left. We will shade going right. And there's our little 2 right there in the middle. So basically, what is this graph coming down to? It basically says x does not equal 2. It's everything but x cannot equal 2. All right? That's your graph. That's your inequality there. You can come back and use the OR approach. You can use that the same thing. It means the same thing. But that's a nice short way of getting to it. All right? X is not going to equal 2. So that's pretty cool. Let's take a quick look at one going in the same direction. All right? Here we go. Get this one a little lined up better. There we are. And we're at 3. Open circle it at 3. Here we're going to open circle it back at 0. And both of these, notice, are greater thans. So we're going to take it greater than, and we're going greater than. This is where they're going in the same direction. Real quickly here at the end. The OR means we're going to take everything we've got shaded. And folks, if we look at, go ahead and drop my line, thank you out. And if you'll notice, we have not an overlap, we want everything. It's an OR. That means we include what's in this part, what's in that part, and you know what? This is going to cover right into there. It's going to also take out 3 for you. So it's going to wind up being at 0. It's going to be shade all the way to the right. We'll darken those edges like we did there. Darken all your edges for those greater thans. And there is your solution. What's the final answer on this one? How about it? X greater than 0. So they can go two different ways. They either go in the same direction or they go different directions. Sometimes they overlap for an and you get some nice, pretty in-between things. Sometimes they give you all, which is the or. So again, I hope this helps you a little bit seeing the difference between and and our situations. Basically, if you can graph them, you can solve them. You can solve them when we do some things, all right? And we didn't get to do those nice little call-ins today, but let's go to Facebook one second. You can still reach us there today, all right? And also you can send us email at mathline@tnlearn.org, as well as YouTube, where we will probably see this show popping up sometime, and also those problems of the day. We're back live again this coming week. Be Monday, Tuesday, Wednesday, and Thursday. We'll have Friday out with another specialized segment, but we love it when you tune in, and we love when you call in, and we will see you on Monday.